In this lesson, we focus on Math 142 UKZN edition, equilibrium, friction, and a lot more. And we proceed as follows. Right, we focus on the kinetics of a particle, force and acceleration, chapter objectives, to state Newton's second law of motion and to define mass and weight, to analyze the accelerated motion of a particle using the equation of motion with different coordinate systems, to investigate central force, motion, and apply it to problems in space mechanics. We proceed as follows. Right, I want us to look at this particular situation. Right, a 50-kilogram crate shown in figure 13, 6a, this particular diagram there, rests on a horizontal surface for which the coefficient of kinetic friction is mu k equals 0.3. Okay. Right, if the crate is subjected to a 400 Newton towing force, as shown, determine the velocity of the crate in 3 seconds, starting from rest. Okay, let's discuss this from the inception of the topic and to advanced questions on equilibrium and friction. Right, we have that actually the coefficient of kinetic friction is mu sub k equals 0.3. Right, and we put it with the 400 Newton force. Now the question we're asking is, we need to determine the velocity. We need to calculate the velocity of the crate in 3 seconds, starting from rest. So the question is then, what exactly do we do here? And how do we therefore attempt to approach this particular question? Right, so the couple of things therefore that you need to take into account, it is the notion of the force diagram. So here it's the crate, and if the crate is drawn, the couple of things that you need to take into account, let's actually, as usual in physics, identify the forces that act on the crate. If this is the center of mass, right, we understand a couple of things about this. So it's going to have a downward force through the center, and the downward force through the center is actually the weight here. And this downward force is 490.5 newtons. We have an upward force, and the upward force is exactly the normal force. If we agree together that the applied force is pulling the block in that direction, and it is a 400 Newton force at an angle of actually 30 degrees to the horizontal, like so, we will agree, and we surely agree together that would have friction force here of 0.3. Right, now would have friction force of 0.3, exactly that by the coefficient. Okay, but I want to write the following formula for a variety of reasons. Right, for this to be very clear, so there's going to be mu k times the normal force. And now it's going to be 0.3 because that is the coefficient of kinetic friction, and times n sub c. Okay. If the crate subjected to a 400 Newton towing force is shown, determine the velocity of the crate in 3 seconds starting from rest. Now, if this is the case, the couple of things, therefore, that remain important. If we agree together that as this crate is pulled towards the right, we choose a direction as positive, and we have our f sub x, which is, according to Newton's second law, max, like so. Okay, if this acts like that, what is the horizontal force? 400. 400 cosine 30. 400 cosine 30 is in that direction, which is the horizontal component of the 400 Newton force. But the friction now, if this is pulled to the right, the friction opposes the motion. So the friction is going to be in the opposite, making it negative 0.3 and c. Right, and this must be equal to ma, and therefore the mass is 50. The acceleration we just going to call it A. All right. So this has to do with the horizontal force, the horizontal motion in the direction of the applied 400 Newton force. Simultaneously, there is an upward force which we choose that direction is positive, and it is the summation of the Fy, which is actually the same as MAY, like that. And now we actually, at this point, we're looking at only the horizontal forces that are acting. Now here, let's look at the vertical forces that are acting on this block. And we know very well that NC is one of them, right? It is a vertical force, but we have minus 490.5, which is a downward force when the normal is actually straight up. And the 490.5 is actually what arises as a consequence of the fact that weight itself is mg, like so. Right, so that in the end, then you have the following. So you have therefore the vertical component of the applied force. This 400 Newton force has its own vertical component, but for the vertical component, we take the 400, we multiply it by the sine function. 400 multiplied by the sine of 30. And the result becomes 0 because this quite does not accelerate noticeably upwards, and we actually are able to determine that this is towed, and its motion is actually horizontal motion. Right, so in other words, good. This becomes the first equation, this becomes the second equation, and with these two equations, we need to get the unknowns. Right, because after having obtained this unknowns, then we shall be in a position to, for instance, we need to get the acceleration, because to be in a position to get what is wanted, the velocity of the crate, we're going to use the formula, the equation of motion, V equals V0 plus AC T. Okay, yeah. And it is V final, V initial plus A delta T. Okay, same sort of formula there that obviously is being used. And now we are able to get exactly what is wanted. Right, so we take note of these with precision, okay? So we have exactly that. We have exactly that precisely. We have exactly that. Okay. What then do we need? Okay. In this formula, because we want to calculate the velocity of the crate in 3 seconds, we actually know the time is 3 seconds, but we do not know the acceleration. So we need to find the acceleration from these particular equations. Right. So from these equations, then if we're able to get the acceleration, then we have the time as well. But remember, obviously, this starts from rest, so we know the initial velocity of the situation. So if we have these two equations, we have 400 cosine 30. 400 cosine 30 minus 0.3 is 50A. And then we have NC minus 490.5. 490.5 plus 400 sine 30. Okay, I'm just writing these equations next to each other, and then we'll just manipulate them and then solve for and get the result. So this is 400 is equal to 0. We called this the first equation, and we called this the second equation. We want to solve for the, okay, there are two unknowns, the acceleration and the normal. Okay. So let us continue and get what we need here precisely. Right. And this kind of acceleration obviously is constant acceleration, a constant. Okay. Now, what do we do here? Let us perform some algebra. 400, the cosine of 30 degrees is the square root of 3 out of 2. 0.3. NC is 50A. NC minus 490.5 plus 400. The sine of 30 is 1/2 equals 0. Okay, yeah, so this is the first equation, and this is the second equation. Okay, want to solve for the NC. What do we do? Right, so, okay, we can do this, but it's much easier than we think. It's much easier than we think because this acceleration is only in the horizontal, so it appears in one equation, and we just need to solve for NC in the second equation, which means that we shall just use a calculator and have 490.5 plus 400 sine 30. Right. If we want to save time, we just punch everything on the calculator here. All these can be obtained, and then we can be able to find the normal. Right. So we have exactly this here. So we can just say 490. 490.5. We add 400. And then we multiply by the sine of 30. And then you close like this. And then what is the answer? It's 690.5. It's actually 690.5. Right, so you're going to get exactly 690.5. And yep. Okay, I lost you. Apologies, I lost you. Apologies, I lost you there. Hey. Yep. Okay, so it's minus here. It's minus. Okay, just check. It's minus here because if you transpose this, this is positive and this is going to be negative. Apologies, I lost you, so I did not realize it. And it happens. I think that it's the network sometimes. You forgive me if I lose you. But I was saying that if you transpose this, it's going to be positive and this is going to be negative. So yeah, it's going to be 490. It's going to be 490.5 minus 400 times the sine of 30. Which is 290.5. That's the correct answer. 290.5. So we're going to have here exactly 290. Exactly 290.5 newtons. And this gives us the actual normal component. And we therefore are able to get using 400 cosine 30. 0.3 NC is 50 acceleration. 400 cosine 30 minus 0.3 NC, which is 290.5, which is equal to 50A. Okay, let's get the answer here. So now you then need 400. Right, minus 0.3 times 290.5. Okay, and we're getting this one. You're getting 259.260 1615. And then we divide this by 50. And then the acceleration is actually 5.19 meters per second squared. We can write it as 5.185. Good. So this means that the acceleration is equal to 5.185, which is meters per second squared. What is the velocity? This plus ACT. And then now you have the initial velocity because this one is from rest. 0 plus the acceleration is 5.185. The time is exactly what? 3 seconds. And if you compute this, then you're able to get the 5.185 times 3, which is actually 15.6 meters per second. 15.6 meters per second. And this gives us exactly the acceleration that is required. Right. It gives us the acceleration that is actually required here.
Charles.
Right. So that's what we have.
Yeah. Then
All right. So let's check here. Right, so we have this. Okay, and therefore this is exactly the result. The couple of things. So now, obviously, we've answered this question. And the couple of things that therefore remain very important. If we actually take this into account, the fact that it is the crate that we have here, and this is its center, there is a downward force of 490.5 newtons. And this is the normal, which is indeed a constant force. And you have the frictional force, which is the force of kinetic friction. Yeah, which is 0.3 NC because it is mu K normal, and it is the force of kinetic friction with the coefficient of kinetic friction. Okay, right. So now if we have this, what then do we achieve? Okay, we're gonna have this that is pulled in that direction. The 400 Newton force is straight up, and obviously we agree together that the angle of 30 degrees is there. But in the end, this whole thing is equal to one crate like this. And it can be seen as everything simplifies to the resultant force giving us 50A, which is the horizontal motion. So everything here boils down to really saying this whole crate system moves and accelerates in the direction of the 50A force. Okay, so it is exactly because, I mean, this is what Newton's second law says. So it actually obviously begins from the fact that the summation of all forces in the x direction will be 50A, and that gives us acceleration in the x direction, and the actual resultant force in the x direction. So right. So we continue. We continue. We continue. We continue. Okay, next question. Next question. Okay, yeah, we're trying to build some background here and just to create familiarity with the questions together. And we shall solve a wide range of the TAT questions, etc., like we started in our discussion yesterday evening. But I think that we need to lay some foundation if we are to make significant progress in solving this. A 10-kilogram projectile is fired vertically upward from the ground with an initial velocity of 50 meters per second. Figure 13.7a. Determine the maximum height to which it will travel if A, atmospheric resistance is neglected, and B, atmospheric resistance is measured as FD equals 0.01 v squared newtons, where v is the speed of the projectile at any instant measured in meters per second. So let us look at these carefully. Let us look at these very, very carefully. Right, let us look at these very, very carefully. So yeah, now at this point we determine the maximum height to which it will travel. If then we have this 10-kilogram projectile is fired vertically upwards from the ground with an initial velocity of 50 meters per second, we need to determine the maximum height to which it will travel. Let us look at these together. To what height will it travel? And that is exactly the discussion at the moment. We're interested in knowing the maximum height to which it will travel. And let's take a look. Let's take a look. Right, so we're getting started. Right, so the couple of things, obviously, that you need to take into account. Right, now what then do we have? Here is a projectile you can just draw as a particle like this. What really a projectile experiences is only one force. If you really are saying in part A, atmospheric resistance is neglected. So now we're then saying there is no resistance in the atmosphere, and then the only force that is going to be acting on the projectile is its weight, and the weight will be subject to will be actually subject to the mass. And we know that the weight is mg, which means that the weight is the mass, which is exactly 10 kilograms times 9.8. You can put 9.81 wish, or just 9.8 to multiply these things here. And now if it's 9.81 that you take, the decimal point is going to move once, making it exactly 98.1 newtons. Right. So that is what we then are able to get here. This is the only way force that is going to acting, but the acceleration, because this thing is moving up, it's going to be actually acceleration that is straight up in the z direction. And we agree, therefore, that the acceleration is going to be straight up because it's moving upwards. Now, what then is all this here? What is the meaning of all this? Because in the first case, we're saying, we're dealing with A, atmospheric resistance is neglected. Okay. Okay. So our solution is going to be written like this. The weight is mg, and the mass is 10. The mass is 10 kilograms multiplied by 9.81, which is actually 98.1 newtons of weight. Right. So we continue. So now, which means that we have the plus. Okay, the force. Okay, the motion is in the vertical, and we remember something that our 3D setup here. Our 3D setup is as follows. Let's just sketch that one. Once again, we shall solve tons of questions, so please take it easy. This becomes our setup, our 3D coordinate system. And so this is what we are able to achieve. Right, so, okay. Now we're going to be adding everything because, yeah, we're solving every question, please, yeah. I'm going to bring tons of the questions as said ready, and we shall be familiarizing ourselves with most of the questions on the 13th chapter. So now, what then is the meaning of all this here? Right, so the meaning of all this is really saying Right, it is really saying. What then would the sum of the forces be? Okay, by Newton's second law, it will be mass times acceleration in the z direction. So now, if this is true, then we're able to say the 10A would be minus 98.1. Minus 98.1. The mass here is 10 kilograms. And therefore, okay, we are effectively then saying, if the acceleration is upwards, the only force that is acting here is the weight, whose magnitude is 98.1. But we chose upwards as positive, so the weight is straight down, so it's negative. And the mass is there, 10 kilograms, and the acceleration is a. We want to find something. We want to find the acceleration, and we find it as minus 9.81 meters per second squared. Determine the maximum height to which it travels. Right now, we get to the kinematics part. Kinematics. Right, so now we will use the equations of motion to analyze this particular situation here. Right, so what we're then going to get is the following. Okay, what we're going to get is the following. So we continue as follows. We continue as follows. We continue as follows. Right. Okay, we continue, please. I'm just continuing just now. So now we just are interested in finding the maximum height under the first condition that it is what? There's no atmospheric resistance. Right. So in the absence of atmospheric resistance, then would have exactly that. They have exactly that. So yeah, we're good. Right, we're good. We're so good. Right, we are most certainly so good. Right, we are here. Okay, I'm just continuing just now in a split second. I'm trying also communicate to these other students of mine who are supposed to be here at 4. So right, we are actually going to be doing the kinematics right now, and obviously I'm sure that you're thinking about it and just finishing. I'm trying to create familiarity with these problems, because one of the things that the problems will be asked, and it's very important that you really can relate to them. Otherwise, then it is the best way to learn, from making sure that every problem that is there is actually, discussed. And we just look at how the problem needs to be solved. We state the variables that are involved, and it shall all be well. It shall all be very, very well. So yeah, we are just continuing just now. I'm trying to make sure that my other students are here. I'm just going to speak to the students, because some of the students just join into, okay, because they will just join in the other kids. But now I'll just highlight them and just give them an order. Right. Okay, never mind. That's said. I'm just communicating to them, so they might just join in because it's a good Sunday. Normally our discussion is at 4, but I want to see at 4 to 6 every Sunday. 4 to 6. So I know that I'm encroaching into your time now because I ran a little bit late. So now the 4 to 6, but yeah, we are continuing. Hello, Karabo, how are you? Karabo, how are you? Karabo. Hello, Karabo, how are you? Okay, let you see. Karabo. Hello, Karabo. Karabo can't talk. Right, Karabo cannot talk. Okay, so don't worry, please. Just a minute. I'm trying to speak to the kids so that they know what's happening, because it's normally the high school slot every 4 p.m. Sunday. But I know I'm actually using this time. I want to see how many serious students will join in, and then they can know what's happening, because otherwise they're just there at home and they'll get lost. And I don't want that. Right, so we're good. We're good. Okay, we are. Yes, Karabo, how are you? Karabo. Okay,
Hi,
yes, how are you, Karabo?
I'm good, and you?
Good. Why were you not talking before? When I was greeting you, you were quiet.
The internet connection is very good this side.
Oh, okay, all right. So welcome, Karabo.
Oh, thanks.
Are you from one of the WhatsApp groups? Which WhatsApp group are you in?
Met Judah.
Okay, that's fine. Right, so that's okay. So now, Karabo, it's my first time to see you. Actually online.
What?
It's my first time.
Sorry?
It's my first time to see you online. Is that correct?
Yes.
It's your first time to join in. Is it true or false?
True.
True, right. Okay, that's fine. So it's exciting then, Karabo. So you need to make sure, what grade do you do? 11 or 12?
I'm in trouble.
All right. So you need to become very serious now, because you're writing the trials. When is your mathematics exam?
21.
Okay. 21 what? Which month?
August.
Okay. What's your province?
Limpopo.
Limpopo. Okay. So yeah, you need to be very serious then, Karabo. All right. Yeah, I was just greeting you, but
Yes.
also you need, yeah, because now you see, you are not registered. I'm just seeing you because you're on the WhatsApp group, but you are not registered. Why are you not registered?
I didn't know.
So now you know, because
Yeah.
you're supposed to register a long time ago, but you're not registered. As much as you have been on the WhatsApp group, but you're not registered, you see.
Yes.
Yeah, so you need to register. Okay.
Okay. Yes.
Yeah, you need to register so that we can know you. And you can
Yeah, I will
participate.
register.
Yeah, so that you can participate very often. You can be able to join in more often.
Yes.
Right. All right. Okay. Thanks, Karabo. Okay. Take care. You can watch part of this lesson. Okay. Right. Now
Yeah.
we are looking at the kinematics part, and now we are taking note of the fact that we're interested in this particular projectile reaching maximum height, and when it reaches maximum height, it means that the final velocity becomes 0, and the initial velocity becomes the velocity which was projected, which is 50 meters per second plus. And then we have here 2 times the acceleration. Right, so the acceleration obviously is negative 9.81 meters per second squared. It's going to reach a maximum height and from an initial height 0. Then we use our calculator to compute the final result to this question. We want to solve for the maximum height that is reached by the projectile, and I'm launching a calculator. Right, so I'm launching a calculator, and this is the calculator. Okay. Now, let's do these together. So if this is the calculator, we're going to take this 50 squared, we move it to the other side, making it negative. So it's going to be negative 50 squared. Okay, and then we divide by this. What is that? Open bracket 2 times. Let's see if the calculator can take 9.81. Okay, it's taking a multiplication with a negative, and we close this way, and we actually press an equal sign, and it is 127. 127.42. Right, so we're getting exactly 127.42, so you can take it as 127 meters. Okay, yeah. We round it off to the nearest unit. So it's actually 127 meters. So we are really saying we have to determine the maximum heights to which it will travel if atmospheric resistance is neglected. That is the situation. So if the projectile is fired from the ground and it goes all the way up, it moves in the Z, along the Z-axis. Right, so as it goes up, it is accelerating upwards, but because it's accelerating upwards, the acceleration is negative. It is a form of deceleration. Deceleration. So the summation, now the weight is mg, which is the mass, 10 kilograms. The gravitational acceleration is 9.81. Okay, for the weight, which is obviously straight down, then the weight becomes 98.1. But we take note of the fact that the actual value of the gravitational acceleration g is 9.81. It's 9.81, not just 9.8, as we used to in the what in school, but the summation of the Fz forces in the z direction would be by Newton's second law, MAZ. Okay, the vertical forces that act there, please, it's only the downward force, and which was upwards is negative. Anything downwards is going to be negative, making the acceleration also negative, because the acceleration is upwards. This object is moving upwards, but the acceleration in particular, we always say gravity is always downwards and the gravitational acceleration is always downwards, making it negative. Then we put everything here, and then we're able to get the maximum height reached by the ball. Saying atmospheric resistance is neglected, the maximum height is 127 meters. Okay, we're trying to create familiarity. Let's look at the next thing. In part B, we are saying the atmospheric resistance now is measured as Fd equals 0.01 v squared newtons, where v is the speed of the projectile at any instant measured in meters per second. Right, and what we want to calculate the maximum height. If we have been given the Fd, and which means that Fd is 0.01 v squared newtons. This becomes the force that is measured, right, experienced by this particular object there, right? And this force tends to retard. It tends to retard or oppose the upward motion, sort of a drag. Right, so at this point, if this is the atmospheric resistance, this is the drag, opposing the motion of the projectile. And if the drag then acts on the projectile, then it tends to do what? It tends to retard the upward motion. It tends to retard the upward motion. Okay, when this is going up, then hang on, this is saying go down. So let's look at the equation of motion. So we look at in two ways. First, we look at the equation of motion. Right, look at the equation of motion, which is exactly upwards. You would have the summation of Fz, which is actually MAZ. Okay, let's see. Um, right. Okay. Um, okay, yeah, we're continuing, please. Okay, we're looking at the fact that if ever it happens that this is the drag, we are now not ignoring a resistance. We're saying there is a resistance. Very popular at metric level, for example, that they say, okay, a resistance is ignored. But sometimes you can say we are not ignoring it. We're taking it into account. And therefore, the summation of the Fz in sigma notation of Fz equals MAZ, Newton's second law. So we continue. We continue. We continue as follows. We continue as follows. Right, so the equation of motion is therefore this one. So okay, we have the summation is this. Okay, we continue. We continue. Now let's actually analyze this particular question together and see what happens here. So the equation of motion now is going to be this. Minus 0.01 v squared minus 98.1, which is 10a. Right. Okay, we continue. So then we get exactly this. We get exactly this. So let's analyze what this means. So the couple of things that are involved here. So this is true because it's the sum of the forces in the z direction. So now when this object, the projectile itself, is in flight, you're going to have the weight, which is exactly 98.1 newtons. And then you're going to have the drag, the force that pulls it down, which is FD. Okay, we agree that in the process, what is actually happening is that this is the Z vertical direction and the acceleration is straight up because this is trying to move up, but weight, the earth is pulling it actually downwards with its weight, but also the drag resistance, there's atmospheric resistance. So as much as this projectile is going up, but hang on, the atmosphere is saying, hang on, the air, the atmospheric resistance, call it atmospheric resistance, it's actually pushing it down, but also gravity is saying, hang on, you must come down. Whatever goes up must come down because of gravity. And there are two forces dragging it down. And therefore, we are effectively then saying, irrespective, regardless of what happens, we are celebratory because we are effectively then saying at this point, this is minus FD, which is the drag, but also it is minus the weight, which is straight down, and the weight is straight down, and also the drag is straight down, okay? The weight is straight down, the drag is straight down, And they are basically the only forces we can identify. And as they act now, it becomes 10A. By Newton's second law, the sum of all the forces will equal the mass times the acceleration. The mass is 10 kilograms, and the acceleration becomes A. And therefore, we have that this is minus 0.01, like that. So what do we achieve? What do we achieve? We achieve exactly this equation. But now what do we want? Right, we want to determine the maximum height. We're good. We're good. We're good. We're good. We're good. We're good. But now there's more we can say. There's certainly a lot that we can say. But let us make acceleration the subject here. So if we have 10A is minus 0.01, V squared minus 98.1. You divide through by 10, and you divide through by 10, you're going to get this one. It's going to be minus 0 point. There's going to be an extra 0 here, minus 0.001. V squared minus exactly the 9.81, like this. Okay. We're good. But now, with this mentioned, there's something we call the kinematics. So look at kinematics. Kinematics. Right, let's look at the kinematics. So the kinematics is going to be, it goes up like this, plus, and then you would have the following. Right, so if the kinematics is straight up and we're looking at the fact that it is moving upwards and we're choosing upwards is positive, we will get the following. So this acceleration, because of the drag, acceleration is not constant here. We note that one down. We're saying here, acceleration is not constant. Acceleration is not constant. Since Ft depends on velocity, right, acceleration is not constant since Ft depends on velocity. So the acceleration is surely not constant. Since the drag depends on the velocity, because the drag depends on the velocity, it means therefore that the acceleration itself is a function of the velocity. Right, because the acceleration is a function of the velocity, we use the formula A times dz. A dz is V dv, which means A dz is equal to V dv. And this one is used whenever the acceleration depends on the velocity. Whenever acceleration depends on velocity. Acceleration depends on velocity. Okay, what is acceleration? Acceleration is minus 0.001. This squared minus 9.81. So the acceleration is minus 0.001. Okay, we divided this one by just 10. V squared minus 9.81. Okay, minus 0.001 V squared minus 9.81. That is acceleration, and this is exactly what? This is exactly dz is equal to V dv. We want to get So now we actually want to be able to get the maximum height. So to get the maximum height, we want to get dz. So we make dz the subject here. So that dz becomes v dv, you divide by minus 0.001 v squared minus 9.81. Okay, yeah, we divide by this. We get dz. We want to get the maximum height, so yeah, we want to get the z. So with this equation, and now this equation that's associated with the drag force, the resistance, air resistance, atmospheric resistance. Then we compute. We compute the integral. Right, we compute the integral from 0 to h, where h becomes the maximum height. We have the integral of v dv divided by minus 0.001 v squared minus 9.81, like this. So what have we done? We want to get the maximum height, and therefore we are using we're taking the integral both sides. Taking the integral both sides. This is dv. This is exactly dv. But this dv now is a v on top. And we then have the integral from 0 to h dz, and this equals. Okay, now this integral here, in the previous question, we understand. Right. Right, we actually need to take note of the following. Remember that it is fired vertically upward from the ground with an initial velocity of 50 meters per second. Okay, so if this is the case, initial velocity of 50 meters per second, so it's going to have an initial velocity of 50 meters per second, but at the maximum height, it's going to have zero velocity. But it was projected initially at 50 meters per second, and then at the maximum height, it's going to stop. Minus 50 initial, 0. V dv. You divide by, okay, pull out the negative because this was negative, pull out the negative so that we have 0.001 v squared plus 9.81. Right, 0.001 v squared plus 9.81, like this. And what is the meaning of all this here? This is all integration. But this integration is a very, very important integration, but very, very easy. What do you do? You need to take note of the following. You can pull out this one, 0.001, you can factor it out. Okay, there are many things you can do. Okay, what is the derivative of the denominator? This should be 2 times this by differentiation, which is 0.002. One thing you can do is to put 0.002 in the numerator. So you're going to get the integral from 0 to h dz. And then you have minus 1 over 0.002. You have 50 a. Then you have 0. Okay, you have 0.002 v dv. You divide everything by the following. 0.001 v squared plus 9.81. Okay, so we have exactly that. We have exactly that. So now what we then have in here is exactly this. If you find the derivative of this, the derivative of v squared is a 2v times this. So we have exactly that. And then as a consequence, what we're then able to achieve is straight integration. So the integral of dz becomes z. It becomes z to integrate from 0 to h equals minus 1 over the 0.002. The integral of this becomes the natural log. Okay, you see.
Ilethe ngibone.
Right. Okay, that's a good question. Are we using integration by parts? Well, at this point,
Manje
we
ayivuleki.
are using integration by substitution.
Ha?
Right. Okay. Yeah. Forgive me.
Sorry.
Somebody's talking. I don't know. Right. There's integration by substitution. Right. There's integration by substitution. Right. So the integration by substitution is as follows.
Sorry.
What is integration by substitution? By substitution, it means that if you have a function f of x,
kanjani?
x whose derivative is in the numerator, right, and then we shall have the following, right, we shall have the following, right, so we shall have, okay, we have function f of x whose derivative is in the numerator, then this is the same as the natural log of f of x plus c. Okay, there's integration by parts. We used it in that other lesson last time, which we had integration by parts. But here we use substitution. If ever you have something like a function whose derivative is in the numerator, then the answer becomes the natural log of the denominator in modular signs plus c, which is 0.001 b squared plus 9.81. Okay. All right. So now this becomes what exactly we're getting. So in the end, we're able to achieve this, which is therefore the integral from 50 to 0. The integral from 50 to 0. Okay, I'm just gonna give examples on this kind of on this type of integration. Right. So now if you have z, so you have z from 0 to h equals minus 1, 0.002. Natural log. The natural log of 0.001 v squared. Right, so we have the v squared plus 9.81. Okay, we had to spend time with integration by parts so you can learn the techniques, because we used it last time because it was part of that problem about the center of mass of a wire, right, or center of mass of a rod. So now this one is from 50 to 0. Right, so in the end, it then becomes h minus 0. Okay, substitute here h minus 0 minus 1 over 0.002, the natural log. Okay, so 0, 0, 1, and then here you put 0. 9.81 minus natural log 0.001, 50 squared plus 9.81. Here you have this, which means h is minus 1 divided by 0.002. Right, we have natural log. Okay, so this is going to be 0, and then we have the, okay, 0 squared is 0, times 0.01 is 0, meaning we have the natural log of the modulus, or the absolute value of 9.81, minus the natural log of this one, which is 50 squared plus 9.81. Okay, so, all right. Right, so 0.001, 50 squared, 9.81. Which is actually 12.31. 12.31. So here you're going to have the natural log of 12.31 because it's 0.001 and the 50 squared plus 9.81, and you take the absolute value of that. It is actually exactly 12.31. So you have 12.31. Exactly 12.31, like so. Okay. And what then are we able to get? It's minus 1 divided by 0.002. We have the natural log of the following. So you have 9.81. You divide everything by 12.31, like this. And if you use a calculator, you'll be able to achieve exactly the height we need. What is the maximum height reached in the presence of drag, in the presence of what we call the resistance, atmospheric resistance. Right, so I want us to punch this on the calculator, all this. So I'm going to punch this negative, and then I'm going to punch this particular fraction 1 over 0.002. Right, and you punch the natural log. Then you go to this one here, which is exactly 9.81. You divide everything by 12 point, right? Yeah, 12.31. And you close like this. And what is the answer? It is 113 point that. It's just about 114. What an awesome answer. So now it means that 114 meters. Let's look at this. In the previous calculation, we agreed that here's the projectile and it's being fired vertically upwards, but it is reaching a maximum height of 114 when we have atmospheric resistance. We saw earlier on that in the absence of air resistance, atmospheric resistance, it was able to reach a maximum height of this much. It was able to reach a maximum height of 127 meters. What does it mean? 127 meters without air resistance. And then with air resistance, so we saw that it was h equals 127 meters when there was no resistance. When this projectile was just moving, h is 114 meters with resistance. So what then is the position here? Resistance is slowing down and reduces the height because it's only 114 meters if there is air pressure and the atmospheric resistance, then the ball does not go so high. But if you remove the wind and you remove atmospheric resistance, we can see that, hang on, this object will go very, very high. We continue as follows. Okay, I want us to look at what happens in the tracks. There's a track here, and this track is a track in this section we're studying on what we call the normal forces and friction. The baggage track A, shown in the photo, has a weight of 900 pounds. Has a weight of 900 pounds. There it is. And tows a 550-pound cart B. There's cart B of weight 550 pounds. And a 325-pound cart C. There's another cart, right, that is being towed. So this baggage truck is dragging two carts, right? It's dragging two trailers. In the South African language, you could call this a trailer, and obviously it can be called a cart there. Okay, right, or a caravan. Some people would call it, so it's like dragging a caravan. Okay, right, for a short time, the driving friction force developed at the wheels of the truck is Fa equals 40 pounds. Okay, they're saying here, right, for a short time, the driving friction force developed at the wheels of the truck is exactly 40 T. Right, we know the friction force, and the friction force, you can just write it here, Mr. Examiner, is 40 T. Right, and this is actually the force. Right, and what then do we have here? LB for the pound, where T is in seconds. Right, if the truck starts from rest, it begins from rest. There is the truck and it's dragging the two caravans, the two carts, is dragging the two carts. Cart B is one of the carts, and then there's cart A as well. Determine its speed in seconds. Determine its speed in seconds. Also, what is the horizontal force acting on the coupling between the track and cart B at this instant? Neglect the size of the track and carts. Neglect the size of the track and the carts. Okay, let us look at what is happening here. Let us look at what is happening. Always, but yeah, always. When we start these kinds of topics, the questions, we look at them like this. We look at them in one length, but one length only. And we say, we look at the equation of motion. We focus on the equation of motion. What is the equation of motion? The equation of motion is that, hang on, when this track, baggage track, is pulling everything, we are happy to say in the physics concept, we take here the original direction as positive, so that the summation of Fx is equal to Max. Like this. So that in the end, we would get the following. You'd get the following. So FA is therefore 40T. So this means that you'd have 40T, which is actually the force, FA. And it is equal to what? We're interested in the actual mass. What is the mass of this here? Right. So what is the mass of this? We know very well that at this point, we have the following. 900 is actually the associated weight of this plus, right, plus exactly 550 plus 325, and this is all divided by what? It is divided by 32. Right, it's divided by exactly 32. 32.2. Okay? And it is multiplied by the acceleration A. Let us take a look at these, because you have the 900 pounds, the 550 pounds, the 325 pounds. Okay, and the 325 pounds is exactly what you then have here. And now what then happens is the following, right? So in the end, you are attempting to then say, what would the overall mass of this system be if we regard it as one overall system? Right, so we add all these particular weights, the 900, the 550, and the 325, we add them all up. Right, now, after having added all these up, we then say we are most certainly in a position to analyze this, but analyze this very carefully. All right, so we're good. Right, so in the end, we have exactly the following. We have, so in other words, we're using Newton's second law, which means the sum of the forces in the x direction will be the same as MAX. Okay, we're gonna obviously explain this more in detail, but we actually continue to analyze these accordingly and see exactly what is to be done here as a matter of fact. Okay, right, so we continue. So that in the end, if this is what we get, what would the acceleration be? So you use a calculator to get this one. You take 40, you divide by the result here, which means A would be 0.725 6 T for the time. Okay, so take note of these and make sure you understand these very, very much. Right, take note of these and make sure you understand these very, very much. So we continue to analyze these a little bit further. Now, after having seen this, we're going to obviously look at these in detail, but this, what we call kinematics, this was an equation of motion from Newton's second law, but now there's something called kinematics. Right, kinematics is what we use next. After first we consider the forces, and then we actually therefore look at what we call the kinematics, the equations of motion that are involved here. Right, so looking at the kinematics, we have the following. So the kinematics is going to be what? It's going to be actually coming from this guy. What exactly is this guy? Kinematics is going to emerge from the fact that acceleration itself is 0.7256 t, which means that we have dv dt, which is 0.7256 t, which means that you have dv, which is 0.7256 t dt. We actually have that dv is 0.7256 t dt from the previous calculation, and then we can be able to get the, okay, we want to get, what do we actually want to achieve here in this particular question? If the track starts from there, determine its speed in 2 seconds. So you want to find the speed in what? The speed in 2 seconds. Right. So what is the speed in the 2 seconds? So you find this one. Right, so we have this one, 0 to v. And then now in the 2 seconds, So you then say, the time here is from 0 to 2. You can say 2 seconds like this. And it is 0.7256 t. The velocity becomes 0.7256 t squared over t. It is integration. We're using integration that says that if you have t squared dt, it is 1 over, normally we state it in terms of the n formula, okay? So which means therefore if it is t to the power n, t to the power n like this, it becomes 1 over n plus 1, t to the power n plus 1, plus the arbitrary c constant of integration. So that now in the end, you then have this one, it's 0 to 2, like this. Okay, let's compute, which is 0.7256 out of 2, which is actually 2 squared minus 0. Okay, if 2 squared divided by 2, it's a 2 times this. 7256. 7256. So 2 times this. 2 times this. Okay, let us check. Can use the computer here. Calculator. Right, use the calculator to actually compute the actual speed that is required. So the speed is going to be 2 times 0.7256. And we get the answer. It is 1.45 feet per second. Or per second, which is 1.45. So it's 1.45 feet per second. Okay, this is a problem that would be mostly for the British. for the British, because the British are the ones who are using what? Right, are the ones who are using the pound as a unit of force. Are the ones who are using the pound as a unit of what? As a unit of force. But now, obviously, we use the Newton. We use the Newton in South Africa, but now some people in other countries use other units like the pound, the LB, the pound. Okay, now let's continue. I want us to, okay, but what was the question? I said, just to make sure we've answered it. If the track starts from rest, determine its speed in 2 seconds. Also, what is the horizontal force acting on the coupling between the track and cut B? What is the force that is there? Here is the track, and there is the trailer that the track is dragging. But what is the horizontal force acting on the coupling between the two? At this instant, neglect the size of the track and the cuts. Okay. Equation of motion. Equation of motion. Equation of motion when t equals 2 seconds. Then the summation in that direction is the summation of fx, which is max, which means you have 40. 40 times 2 minus tension, which is, okay, let's deal with this. So the equation of motion now when t equals 2 seconds, because the speed in 2 seconds, want to get the actual coupling force there. So want to get the tension. But now what happens in this case is that we are analyzing, because this horizontal coupling force is a force in the x direction, right? If we are looking at the fact that the vertical is the y and the horizontal is the x in the what we call the Argand diagram, right? In our Argand diagram, or what we call the Cartesian plane, right? So we agree that at this point, the force that is going to be on the horizontal is going to be what? It's going to be 40 times 2. Let me write a little bit more here. Let me write a little bit more. So in principle, we're going to say the forces in the horizontal is going to be Fa minus the tension. And this here is the same as what? Is the same as max, like this. What is Fa? Right, our Fa is 40t, which means therefore you have 40. T is 2 seconds minus the tension. Remember that what is happening here when the track is pulling, the track is in that direction, the tension is the other way. And these two guys are in opposite direction. They are wrestling with each other. The trailer is pulling the track to the back when the track is trying to pull everything. It's pulling the two coaches. It's pulling the two cars, the two trailers, the two wagons from the back. But also by Newton's third law, this is a pull and drag situation. Action, reaction, pair of forces are involved at the point of contact of the track and the carts. I want us to analyze and see what happens here. So Fa, remember, it's actually now this horizontal force that the track is driving. And now it is because of the engine of the truck, of course. But the tension there is pulling the truck to the back. Now, if we look at this, now dealing with the track alone, we know very well that the actual weight of the truck is actually this one. What is the weight of the truck? The weight of the truck is 900 pounds divided by what? Right, divided by 32. 32.2, like that. And we multiply this by the following. Multiply by the acceleration in the x direction. What is the acceleration in the x direction? we saw before that the acceleration in the x direction is exactly what? The acceleration in the x direction is what we got. It is 0.7256 t, 0.7256 t, which is 0.7256 t, and this is 2 like this. Okay, so what is the tension? Okay, use a calculator. You multiply this and take the t to the other side and subtract with the calculator, and you're gonna get actually the tension is 39.4 lb pounds. There's the unit of force. Right. So yeah, it's something that you need to take into account and make sure you sort of understand and make sure that everything is okay. Right, everything is okay, and now you are able to understand everything very, very well. Right, very, very well. Okay, so take note of that. Take note of that, and make sure that you are able to actually understand every single bit of thing, every single bit of what we're doing. Right, every single bit of what we're doing. Yeah, just take note of that and make sure you are able to follow. Think about this particular question, and just to make sure that you are able to understand what is happening exactly in this particular situation here. Right, and you must be able to understand what is happening in this situation. So take note of that. Right, so take note of this exactly. Right, so yeah, so we continue then to analyze more questions as we move forward. Okay, let us look at this one. A smooth 2-kilogram cola. Right, 2-kilogram cola shown in figure 13.9a is attached to a spring having a stiffness K equals 3. Okay, K equals 3 newtons per meter and an unstretched length of 0.75 meters. If the cola is released from rest at A, there's the cola released from rest at A, determine its acceleration and the normal force of the rod on the cola at the instant that y is equal to 1 meter. At the instant that y equals exactly 1 meter. Let's look at these together and see what you need to do here. Let's look at these and see what you need to do. A smooth 2-kilogram cola is shown there. Here is now it is shown that it's attached to a spring having a stiffness K equals that. Here is the cola. Here is the cola. It is attached to the spring and the stiffness, right, K equals 3 newtons per meter. And an unstretched length. Okay, if it's not stretched, the spring has a length of 0.75 meters. If the cola is released from rest, somebody releases the cola from rest, determine its acceleration and the normal force of the rod. If the cola is released from rest, if the cola is released from rest, it's A, determine its acceleration and the normal force of the rod. Okay, if it's released, it goes down like this, and this is stretches, the spring stretches. Right, so need to determine its acceleration and the normal force of the rod on the cola at the instant y equals 1 meter. At the instant y equals 1 meter. Let's see this one. Let's see this one. First things first, we always look at the equations of motion, and then we do the kinematics part of it. So we actually obviously look at that. But first things first, sometimes that becomes so important is to analyze first what you call the free body diagram. Free body diagram to see what is happening to the collar. So right, so we have the free body diagram. Right, so in this free body diagram situation, what exactly do we have here? What do we have here in the free body diagram? Right, so the couple of things that we'll take most certainly into account, it is the fact that if this is the collar, and you analyze the coordinate system, y vertically and x horizontally, okay, y vertically and x horizontally, and we understand therefore that now it's going to be moving downwards and therefore it's going to be accelerating downwards. But this kind of acceleration, please, it's not the acceleration due to gravity in terms of free fall, because this is not in free fall, this, right? It's not in free fall, it is just sliding down, and it will have a weight which is 19.62 newtons. Right, and then now you have this one here, which is the force of static friction. Right, which is in the end then the normal force that is going to rise. Right, so there's going to be a normal force that's going to be experienced. Right, so there's going to be an angle theta that obviously can be determined there. And we then have exactly the following point. Right, we then have the following point. So if ever we look at this very carefully, you are able to see the free body diagram, but we need to actually examine this and see what to do next and see exactly what to achieve at the end of this. Right. So we're good. Now, there are certain things you need to take into account here. So we have a rough sketch of the free body diagram. And we take note of this particular free body diagram. Right, and the acceleration that is downward. Right, and we have the forces that are acting as shown there. Okay, we're good. But let us analyze now the equations of motion. Right, we're looking at the equations of motion. Equations of motion. Right, so now the couple of things here, like if you have the summation of fx is max. There's a force that is straight down. Summation of fy, which is may. So that then in the end, what we're saying, the sum of the forces in the x direction. The sum of the forces in the x direction. What are they? So if this is the free body diagram, we're able to see that the minus normal force plus the horizontal component of the force would be Fs cosine theta. That is the horizontal component of Fs. That is the horizontal component of Fs. Remember, when determining the acceleration and the normal force of the rod on the collar at the instant that y is actually 1 meter equals 0. Sum for the forces in the y direction. Let's look at the sum of the forces in the vertical. We have the 19.62 Newton force. And then this is minus FL sine theta. Okay. Now what do we get here? This one is straight down, but if you look at the FS force, it's going to be upward a little bit. And this is straight down, so they're in opposite directions. Upward vertical component. And therefore, this is sort of what you're going to have here. Right, so if it is an upward vertical component because of the fact that it is in that direction, so that is upward this way. Right, and what then are we able to achieve here as a matter of fact? Okay, you have the horizontal component there of the force also. And this horizontal component of the Fs is in the opposite direction to NC, but now this one, the 19.62, and the vertical component of the Fs force is Fs sine theta. Right, and this here is going to be the mass times the acceleration by Newton's second law. The mass is 2 and the acceleration is a. Right, this is what we have. This is exactly what we have. Okay. What then are we able to achieve here? Right, what are we able to achieve here? Okay, what are we able to achieve here? Okay, we continue. Right, we continue. Right, now, the couple of things then that are very, very important for us to take into account. Right, there's something we call the magnitude of the spring force, something called the spring force. What is the spring force? The spring force is F sub S, which is the spring force, equals Ks. Right. We know that the distance from A to B when the spring is not stretched, we know that AB is actually the same as 0.75 meters. What is S? CB minus AB. What is CB? What is CB? So now CB, now you need to find, this is C and this is B, and then you can use Pythagoras theorem. Using Pythagoras theorem to find CB, this is a right angle triangle. This angle is 90 degrees here. And the length of CB becomes exactly what? Becomes exactly y squared plus 0.75. And then you square this. Okay, this is CB because you are having the y squared here and the 0.75, and then you find the length of the hypotenuse. This is called Pythagoras theorem. AB on stressed spring is 0.75. And this gives us the actual S, which is the stretching of the spring. Right, the stretching of the spring. Right, because that is what we need to do. Now we continue and then we say the spring force is Ks. And we know that the K is 3 newtons per meter. 3 newtons per meter. We've already got that one. The S, which is y squared plus 0.75. Like this. Minus 0.75. So then the question you're asking is, what is the angle theta? Because here there is theta. What is that angle theta? So we're able to see, therefore, that the tangent of theta is opposite of hypotenuse, rather opposite of adjacent from SOHCAHTOA. SOHCAHTOA, which is actually opposite of adjacent, which is y over 0.75. Right, so we have the following. Okay, you have this one is 0.75. TOA, opposite of adjacent, opposite of adjacent. Okay. So now we have these two equations. So we substitute y equals 1 into equations 3 and 4. And this yields we continue. Right, so we continue. Right, that's fine. I'm gonna stop. I'm gonna stop after 5. I should stop after 5 because I started around 3, so it's about 2 hours already. Substitute y equals 1 into equations 3 and 4. And this yields the following. So it's gonna yield the following. So if substitute y equals 1, because we're interested in determining the acceleration and the normal force of the rod on the collar, right, at the instant that y is 1. So you're going to put y equals 1 there and then be able to get the fs here, and then we are able to get the tan theta also, right? And now the fs is 3 1 squared plus 0.75 squared minus 0.75. Okay, we're going to get an answer here. And then now here we have tan theta, which is 1 divided by 0.75. And theta therefore becomes arctan, 1 divided by 0.75. And then you get the answer here. So right. Right, so now you have 3 times the square root of 1 plus 0.75 squared minus 0.75. Okay, which is like 1.5, 3 over 2. Right, so I have just done the force spring, what do you call the spring force? Right, I've just done the spring force. Right, so now, okay, I'm gonna release you. I'm gonna take a break. Right, so which is actually 3 over 2, which is 1.5. Right, the spring force, which is 1.5, right, 1.5 newtons. So now, what then are we able to achieve here? Right, what are you able to achieve? Okay, we can even be able to get the angle theta. What is the angle theta? Okay, let's use the calculator quickly. We're finishing, please, because I know that you have your own church and things, and yeah. And then we shall return. Right, so now this is arc10. Shift 10 of 1 divided by 0.75. And then you do this and then you close there. 53.13, 53.1 degrees. That is the angle. So you're getting exactly 53.1 degrees. Okay. What do we want? To determine its acceleration and the normal force of the rod on the collar at the instant. So we have found a couple of these things, like this spring force, or what you call the spring force. We found it, and the angle, we found it. But we're interested in determining the acceleration. So what will then the acceleration be and the normal force? So we need NC and that. So we continue as follows. We continue as follows. We're finishing. Right, so we go back to these particular equations, and these particular equations are good, like this one. It's already like this equation, minus NC plus Fs cosine theta. Right, so minus NC plus Fs cosine theta is 0. I'm reducing you, please, I know. I'm running out of time. Minus NC plus Fs cosine theta equals 0. Okay, so which means that NC is equal to Fs cosine theta. And then this one, what is the Fs? The spring force. It is 1.50. Yeah. 1.50 cosine theta. 53.1. 53.1 degrees. Okay, use the calculator. I'm gonna use it. Okay, because we need to find the normal force, and this is the normal force. Just need to calculate this one here from one of the equations. And the acceleration and that. So the acceleration is going to come from this equation. Acceleration is going to come from this equation because this equation has acceleration. And then we're just going to put the spring force. Right. So in other words, we shall put the we shall put the 19.62 and everything. Right. So here we shall put the 19.62 minus Fs sine theta, which is 2a, which is 19.62 minus Fs. What is the spring force? 1.5. The sine, what is the angle? Theta is 53.1. We need the acceleration, so we can just divide by 2, and then we're going to get the acceleration. So, yeah. Yay. Okay, yeah, we're finishing. And then I'm going to release you so that you can go to the church and do your things, which is good. Okay, yeah, I'm going to do the normal force. Just want to confirm these answers. 1.5 times the cosine of 53.1. And then obviously then I'm going to meet you again at what time? Okay. Right, which is 0.900. 0.900. It is the normal force, which is in newtons. And then the acceleration, let's find it. Which is 19.62 minus 1.5 times the sine of 53.1 divided by 2, which is 9.21. Which is 9.21 meters per second. Okay, yeah. So we found the acceleration and we also found the It wasn't fun, the normal force. All right, I must thank you guys for joining us. It was awesome, awesome. Right, to have you. We shall continue again later on. I'm sure that we have to continue at 11 p.m.